This video is by Dr. Rebecca Garris, Colorado School of Mines. I'm making this video for my students because I've been spending all my time grading exams, and I'm guessing that I'm not going to have time to get comments on your Jamboard pages in a reasonable amount of time. So I figured I could make these videos, and I'm just going to talk through how I would do these problems from your activities. So I'll make one for 11.1 day 1, 11.1 day 2, and 11.2 day 1. This is the first video, which is 11.1 day 1. So our goal is to find Taylor polynomials for a specific function and a given center, and then use that polynomial to approximate a specific value, which may or may not be a known value. So let's see how that works. For this first one, number 1, we're finding a degree 3 Taylor polynomial, P3 of x, for f of x equals cosine of x, centered at a equals pi over 2. Next, we're going to use our Taylor of polynomial to approximate cosine of 3 pi over 4. So it's all going to start with this polynomial that's written in a general form, in that compact summation form. What does that actually mean? For a degree 3 Taylor polynomial, we can write that out in the general form. And I'll just put it in terms of a for now, so for a general center. So P3 of x is equal to, we're starting at k equals 0. So the 0 derivative means don't take a derivative. So that's just f of a. 0 factorial is defined as 0, and then x minus a to the 0 is just 1. And then we get a linear term, f prime of a, divided by 1 factorial, which is just 1, so I'm not even going to write it, times x minus a. Then we get a quadratic term. We get f double prime of a divided by 2 factorial, which is just 2, but I'll write factorial just, to follow the pattern. And then we get an x minus a squared, and then we have a cubed term, which goes with our third derivative of f, evaluated at a, divided by 3 factorial, and then x minus a cubed. That's what it is generally. So you can see what we're going to need: the function evaluated at a, the first derivative evaluated at a, the second derivative, and the third derivative, all evaluated at a. So let's get started with that. First, we need to find the derivatives as a function. F of x equals cosine of x. We take one derivative to get the first derivative, and we get minus sine of x. The second derivative is just taking the derivative of minus sine of x, which is minus cosine of x. And then the third derivative at x is the derivative of minus cosine of x, which gives us positive sine of x. Those are the functions. They all depend on x, but we want to plug in the a value. And in this case, a is pi over 2. Okay, so f of pi over 2 is equal to cosine of pi over 2, which is 0. We can even picture our unit circle if that would help. Here's the unit circle. Pi over 2 is looking up here, straight up. And the cosine is the x component, so the x component is 0. F prime of pi over 2 is minus sine of pi over 2. Sine of pi over 2 is 1. With the negative sign, we get negative 1. And then f double prime of pi over 2 is 0 again. And f triple prime of pi over 2 is sine of pi over 2, which is 1. So you can see the f of a term and the f double prime of a term are both going to 0, but we'll be left with those other two. So P3 of x is equal to 0 plus negative 1 times x minus pi over 2 plus 0, times other stuff, but we'll just leave it at 0. And then plus f triple prime, which gives us 1 over 3 factorial times x minus pi over 2 cubed. So if we simplify this, we get P3 of x is equal to minus quantity x minus pi over 2. I'm not going to change the x minus pi over 2. I'm not going to distribute anything because I like seeing it in that form. And then plus 1 over 3 factorial, which is 1 over 6 times x minus pi over 2 cubed. All right, so now that's our Taylor polynomial. We did it. There's our answer there. Next, we want to use that to approximate cosine of 3 pi over 4. Cosine of 3 pi over 4, let's see, that would be equal to f of 3 pi over 4, since f is cosine. And that is approximately equal to P3 of 3 pi over 4. So we get minus 3 pi over 4 minus pi over 2 just leaves us with pi over 4. And then plus 1 over 6 times pi over 4 cubed. And we can plug that into our calculator. Let me do that. Let's see. Minus pi over 4 plus 1 over 6 times, where's my pi? There it is. Pi over 4 to the 3 power. And I get minus 0.705, I'll call it. Okay, so that's my approximation. What's the actual value? Cosine of 3 pi over 4, that would be if we go back up to our unit circle, we're looking up here, right? So this one that we did first was pi over 2. This one now is 3 pi over 4. So you can see this, this quantity here should be root 2 over 2. That's the exact value. Let me plug that into my calculator. Root 2 divided by 2. Oh, and it's got a minus sign because it's in the second quadrant. That would be minus 0.707. So pretty close. It's a pretty good estimate. All right, and that's our answer. The second one, let's look at the second one now. Find a degree 2 Taylor polynomial for P2 of x. For f of x equals square root of x, center to a equals 4. Next, use your Taylor polynomial to approximate square root of 5. So square root of 4, center to a equals 4. Square root of 4 is 2, so that's an easy center because we know how to evaluate that. And 5 is pretty close to 4. So square root of 5 should be a little bit bigger than 2. That's my guess. So again, let's do second degree Taylor polynomial. P2 of x is equal to f of a plus f prime of a times x minus a plus f double prime of a divided by 2 factorial times x minus a squared. And that's all we're trying to do is a degree 2, so that's all we need. So we just need to compute 2 derivatives. We have f of x equals square root of x, which I'm going to rewrite as x to the 1/2 because I like seeing the power. I think it makes it easier to do derivatives. F prime of x is equal to 1/2 x to the minus 1/2, and f double prime of x is equal to minus 1/4 x to the minus 3/2. Now we got to plug in our center. A equals 4. So f of 4 is equal to 2. Square root of 4 is 2. F prime of 4 is equal to 1/2 times 1 over square root of 4, which is 1/2, and that's 1/4. And then f double prime of 4 is equal to minus 1/4 times, let's see, 4 to the minus 3/2, which is equal to minus 1/4 times 2 to the minus 3. So we have minus 1/4 times 1 over 8, which is minus 1 over 32. All right, so there's our coefficients, right? We got our 2, a 1/4, and a minus 1 over 32. And we plug it into P2 of x. P2 of x is equal to 2 plus 1/4 times x minus 4 minus 1/32 times 1/2 times x minus 4 squared. That's equal to 2 plus 1/4 x minus 4 minus 1/64 x minus 4 squared. That is my P2 of x Taylor polynomial. Okay, so next, use your Taylor polynomial to approximate square root of 5. Square root of 5 is equal to f of 5, right? Because f of x is square root of x. So square root of 5 of f is f of 5, which is approximately equal to P2 of 5. So we're going to plug it in. So we get 2 plus 1/4 times 5 minus 4, which is 1, minus 1/64 times 5 minus 4 squared, which is 1 squared. And we plug this into our calculator. 2 plus 1/4 minus 1/64 is equal to 2.234. I mean, there's more decimals, but I'm just going to call it that for now. And then let's plug in. Okay, so that's the answer we were looking for. What is square root of 5 if I plug it into my calculator just to see how good this is? It's equal to 2.236. So as I suspected, it's just a little bit bigger than 2. Definitely closer to 2 than to 3, because I know square root of 9 is 3. 5 is much closer to 4 than to 9. So again, a pretty good fit. All right, let's do another one. Finding degree 4 Taylor polynomial, P4 of x, for f of x equals natural log of x plus 1, centered at a equals 0. Next, use your Taylor polynomial to approximate natural log of 2. Okay, so let's write in general. P4 of x is equal to f of a plus f prime of a times x minus a plus f double prime of a divided by 2 factorial times x minus a squared plus f triple prime of a divided by 3 factorial times x minus a cubed. And then plus, I'm going to stop primes and I just write f with a little 4 in parentheses of a divided by 4 factorial times x minus a to the 4th. So clearly I need to find the first 4 derivatives. Hopefully I have enough room. Looks like it. Okay. I'll write a little bit smaller. F of x equals natural log of x plus 1. F prime of x equals 1 over x plus 1 times 1, which is fine. I'm going to rewrite that as x plus 1 to the minus 1. Because again, it's easier to take a derivative if I have the power rule, if I have the powers written in the numerator. F double prime of x is equal to minus x plus 1 to the minus 2. F triple prime of x is equal to 2x plus 1 to the minus 3. And then the 4th derivative of x is equal to minus 6 times x plus 1 to the minus 4. Now I'm going to plug in my values. A equals 1, or a equals 0. So f of 0 is equal to natural log of 1, which is equal to 0. F prime of 0 equals, let's see, x plus 1 is just 0 plus 1, which is 1, to the minus 1, which is 1. Notice here that all of the x plus 1s are just going to go to 1, and 1 to any power is just 1. So what we're going to be left with is the coefficients. So f double prime of 0 is equal to minus 1 times 1. F triple prime of 0 is equal to 2 times 1. And f fourth derivative of 0 is equal to minus 6 times 1. So there are our coefficients. All right, so we can plug this in. P4 of x is equal to 0 plus 1 times x. A is 0, so x minus a is just x, plus negative 1 over 2 times x squared, plus 2 over 3 factorial times x cubed, and then plus negative 6 divided by 4 factorial x to the fourth. And we can simplify. P4 of x is equal to x minus 1/2 x squared plus, let's see, 2 over 3 factorial. 3 factorial is 3 times 2 times 1. So the 2's cancel, and we're just left with 1/3 x cubed. And then let's do this coefficient off to the side. We have minus 6 divided by 4 times 3 times 2 times 1. The 6 cancels with the 3 and the 2, so we're just left with minus 1/4. Minus 1/4 x to the fourth. And I will highlight that because that's one of our answers. Now notice the pattern here. X minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the fourth. It looks like there's a pattern where we have an alternating sign and then we're adding x's that are divided, x to a power divided by that power. And in fact, that is what we're going to see when we look into Taylor's series in 11.3. But for now, we'll continue. So we are using our Taylor polynomial to approximate natural log of 2. Natural log of 2 is equal to natural log of 1 plus 1. And remember, f of x is natural log of x plus 1. So this means we're looking at f of 1, which means this should be approximately equal to P4 of 1, which would be 1 minus 1/2 times 1 squared plus 1/3 times 1 cubed minus 1/4 times 1 to the fourth. And we could plug this into the calculator for our approximation. 1 minus 1/2 plus 1/3 minus 1/4 is equal to 0.583. And the 3's repeat. Now let's see how good of an approximation this is. Natural log of 2, if I plug it into my calculator just to check, it's equal to 0.693. So is it close? It's roughly close. You know, if I added like, let's see, 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6 plus 1/7 minus 1/8 plus 1/9 minus 1/10. If I go all the way up to 10, like a 10th order Taylor polynomial, right? P10 of 1 is equal to 0.646. So it's getting a lot closer, but this one, clearly you need more terms to have a better approximation. But, you know, this is what we got, 0.583. The actual value is 0.693. The more terms you add, the closer it would get. Okay, and last, let's find a degree 4 Taylor polynomial for f of x equals x cubed, centered at a equals 0. Okay, so let's do that first. I see there's other questions, but we have the Taylor polynomial written up here in general. So I'm not going to write that again, but I'll just draw your attention back to that. So we clearly need to find 4 derivatives. Okay. Maybe I could just copy that. Let's see. That'd be fancy. Oops. Oh my gosh. Oh, whatever. Okay. Okay. Nice. All right. I'll just put it here for a minute so I can look at it. Let's see. Should I crop it? No. Oh well. All right, just ignore the... All right, never mind. We don't need it. Okay, so we're going to need 4 derivatives. F of x is equal to x cubed. F prime of x is equal to 3x squared. F double prime of x is equal to 6x. And f triple prime of x is equal to 6. Ooh, so what happens when we take a 4th derivative of x? We get 0. And what would happen if we took any other derivative, right? And greater than 4 of x would still be 0. No matter how many derivatives we take, they're just going to go to 0. So now let's plug in a equals 0. F of 0 equals 0. F prime of 0 equals 0. F double prime of 0 equals 0. F triple prime of 0, that equals 6, so that's good. And then all the other derivatives greater than that 3rd derivative are going to give us 0, as we've shown over here, because they are 0. Okay, so let's plug it in. So P4, actually I'll just write it over here because we don't need much space for this. P4 of x is equal to 0 for the constant term, plus 0 for the linear term, plus 0 for the quadratic term, plus 6 over 3 factorial x minus 0 cubed, and then plus 0 for that 4th term. Okay, and what is 3 factorial? 3 factorial is 3 times 2, which is 6. So P4 of x is equal to x cubed. Well, that's interesting. So really, we just got an exact polynomial because our function that we started with is a polynomial. That's what I notice. What happens if we find a degree 4 polynomial for f of x equals x cubed centered at a equals 1? Okay, so we'll draw a little line there. Now a equals 1. F of 1 is equal to 1. F prime of 1 is equal to 3. F double prime of 1 is equal to 6. F triple prime of 1 is equal to 6. And f, the 4th derivative at 1 would be 0, as would all terms higher than that. Okay, so let's see what happens. In this case, P4 of x is equal to 1 plus 3 times x minus 1 plus, let's see, 6 over 2 times x minus 1 squared plus 6 over 3 factorial times x minus 1 cubed plus 0. So does the same thing happen? Is this the same polynomial? That's a good question. And what do we think? What's going to happen here? We could expand this all out, and if we expanded it all out, you would see that the only term left is x cubed. Is that a good use of this time? I can. I mean, it's interesting. Let's see. Let's see if I can do it without messing up any algebra. Okay, so we have 1 plus 3x minus 3 plus 6 over 2 is 3 times, let's see, x squared minus 2x plus 1, and then plus 6 over 3 factorial is just 1. So when we do x cubed, ooh, what is it? I think it's x cubed minus 3x squared plus 3x minus 1. And then plus 0, which I'm not going to put. I'm not sure why I'm writing this big diagonal, but we'll see. Can we cancel some terms? Whew. Let's see. I'm going to write much smaller. Okay. So here's a 1 and a minus 1. Those cancel. Now do we have a 3x? Here we have a 3x and a 3x. Those are both positive. But here we have a minus 2x times 3 on the outside. So those are going to cancel. What else? We have a minus 3 here and a plus this 3 times this 1. Those cancel. And then we have a 3 times x squared that's left and a minus 3x squared. So those cancel. And the only term we have left is x cubed. So again, P4 of x equals x cubed. Now, if you just look at this version, it doesn't look like x cubed, but in fact, when you expand it out, it does get you back to the same answer. All right, there you go. Let me know if you have any questions.